source, and we have a test block which is named return true. And this is a block of code, so you can write pretty much anything in it, and you can have as much Next, strings. Strings in Zig are compatible with C, so both hello strings are the same in Zig and in C. As always, for static values, you don't need to write the type in Zig. A string isn't a simple array of unsigned bytes. As in C, strings have a sentinel value, but in Zig this is explicit in the type. This hello value is a pointer on a constant array of 5 elements of type unsigned 8-bit integer, and there is a sentinel value of 0 at the end of the array. In any case, you'll get the right value, 5, when asking for the size. No need for this strlen. Next, we'll see structures. In C, structures are simple and very limited. In Zig, as always, the syntax is quite similar. In this example, we can see two main differences. First, structures are just a value that you can put into a constant here, no special treatment. Then you can have default values. You don't need to write it here. Next, structures can hold public constants, like this. Also, they they can have functions, and it helps organize the code a little bit. It creates namespaces. There is no absolute need to have object-oriented programming. Having just namespaces actually is enough, at least for my needs. Next, we'll see our second built-in function, this. This refers to the current element you are in, the current structure. For example, we are creating here a point, and within its definition, we can refer to it as this. In this example, we use a constant self to refer to the current structure. Having a self constant within a structure is a common practice. Self is later used in the function set for the first argument, here, a pointer on the current structure. Let's see how this structure is used. First, we create an instance of structure point named p, here. Then we use the set function we saw earlier. As we can see, the first argument of the function is implied to be the p variable. There, the same stuff in C. This syntax isn't a big change, still it is simpler to use than in C. This adds namespaces, and then function names become simpler since they are bound to the structures they work on. Simple, not new by any mean, yet powerful. Now that we saw that C and Zig aren't much different, and even if the syntax changes a bit, it still is very familiar. Zig is easier to write and read, despite doing almost the same thing. Zig does add extra instructions like storing array, is very familiar, yet powerful. Now that we saw that C and Zig aren't much different, and even if the syntax changes a bit, it still is very familiar. Zig is easier to write and read, despite doing almost the same thing. Zig does add extra instructions like storing array lengths, but you had to do that anyway, so it was only logical to do that automatically in a consistent way. Now, let's take a break and enjoy some C preprocessor, shall we? You can almost see the C preprocessor . like a cell on a source file. There. Read this code and guess what it does. Sure, they are trying to get a safe divide of x by y, and it doesn't work. This macro is translated this way, which clearly isn't what was intended. Next, a very simple, which clearly isn't. This macro is translated this way, which clearly isn't what was intended. Next, a very simple macro, square. I let you a sec this way, and it doesn't work. This macro is translated this way. Which clearly isn't what was intended. Next, a very simple macro, square. I let you a sec to read it. Now, what could go wrong? Yes, this will compile, and yet this won't work as expected. Next, guess what this program does. Yes, it does seem very simple. In fact, you cannot know. Everything here could have been changed in something.h. Let's see what is its content. Nasty. If now is a macro. And it could have been even worse. Let me introduce you to evil.h. Yes. Next, we have a very simple macro, a simple instruction saying that x equals 0. But when you use it, you don't see that it changes variable in your local scope. You just see a function call. And you know what? With macros, you can get C to a whole new level. What do you know about C? A very old imperative programming language? Nah. It's actually an oriented object programming language with generic data structures, and you can have polymorphic functions, and you can have interfaces. Everybody gets exceptions thanks to libcello. They even add closures at some point. But there are some cons. No type checking. Thanks, but no thanks. Satan. Now that we saw So what could be done using macros, mostly things we really don't want since we cannot control debugging and other minor stuff like that. Let's see how we can replace them. Let's see something familiar in C, macros. Macros help factoring redundant instructions. This is almost a search and replace. We also could have done static inline functions, but combine with macros, so we can have functions working on either integers or floats. On the Zig side, it looks a lot like inline functions in C, except that we have a simple function with the exact same syntax as any other function, taking a type as the first argument. This type is a value known as compilation, comp time, and it is used as a type of the other parameters. And if we want to limit the number of functions in our final binary, we could have used the keyword inline. The keyword number of functions as a type of the other parameters. And if we want to limit the number of functions in our final binary, we could have used the keyword inline. Another way to use macros is to get generic structures. In this example, we create a list of items in a list structure. Another way to use macros is to get generic structures. In this example, we create a list of items in a list structure. So for each type we want, we create a structure list underscore type. Here is the declaration of this list, and here is its first use. In Zig, we can have a function returning the structure we want. Side note, this isn't mandatory. So as presented here, this feels like a very small improvement. In both versions, we still need to perform memory allocations, here and here. And this part is still related to the type of our structure, so this doesn't feel like a good abstraction. For now, I will show to you a real-life example later. Finally, we use a preprocessor for conditional compilation, compiling only stuff we want. If this is defined somewhere in the code, then only this will be compiled. not this. On the Zig side, let's say that this is defined somewhere, and then we have this. Since the switch is on a constant, which is defined once during compilation, there is no point to put other instructions than the right one in the binary. So, since my OS here is actually this value, we will only have this. And the same thing applies with functions if you are referring to constants defined at top level. So you can have this switch in a function if you want. And I also tried some kind of stuff like that, and it is completely useless, but it works. Next, optionals. An optional is a value that can exist or not. For example, in Zig, here, I have a variable named optional value, which is an integer but may not exist. Right now, this value doesn't exist. It's null, but beware, that is not null as in C. This is not 0. In Haskell, you may do that with maybe, and it is quite similar. And to check if there is a value, you can do this conditional like this. In C, we have to hack a bit. Let's say that you have a variable x there, and the function name some function. and this function may change x. So to be sure, you need another variable, so some function can tell you if the variable x was changed, or if it is garbage. Another way is to return a pointer, like this, and if it is null, then the value is garbage. Either way, it's more complicated than it has to be. Next, a quick one, test. It's more complicated than it has to be. Next, a quick one, turn a pointer, like this, and if it is null, then the value is garbage. Either way, it's more complicated than it has to be. Next, a quick one, test. If it is null, then the value is garbage. Either way, it's more complicated than it has to be. Next, a quick one. Either way, it's more complicated than it has to be. to be. Next, a quick one, test. In Zig, there is a test keyword allowing you to execute a block of code. This is an example. You have a function that you want to test, of course, and we have a test block which is named return true. This is a block of code, so you can write pretty much anything in it, and you can have as much test cases as you want directly in your original code. To run the test, you just have to do this. If the test fails, the Zig compiler will provide the name of the test and an error stack trace. Let's see that. Oh no! Panic! So, the test returns true, failed, and this is the stack trace. Next, errors. One of the best things in Zig